access to the information. So we'll go ahead and get back to the simple examples. So what we're going to start with is drawing a simple circle to get a feel for how that works. So we come up here in the sketch menu after we've started our new sketch, and we pick the top plane as if we're drawing something. Instead of drawing it like you would on a piece of paper, you're going to click and it'll show you a representation of the circle types. You can do a 3-point, or you can do 1, 2, which is a center point, and it gives you a graphic here that will help make it a little bit more visible. So you start with a center point, and then you give it a second point, which is trying to define the radius. Next thing that I'm going to teach you is your best friend. You're going to use this for all of everything all the time. Smart dimension. What this tool does is gives a either a diameter for a circle, length for a rectangular shape or something like that. It can also give you angles and all sorts of other things that we'll look at in a little bit. We're just trying to get our heads around how to use this interface. Then you type in the correct dimensions. So if we were to start looking at something like we wanted to represent a pattern of circles for like a top-down view of a drink holder from a restaurant or something like that. It's actually probably a reasonable example. So what we'll do is if you get knocked out of it or you hit a key accidentally or something, just double click on the dimension again. This value we're going to set to be about 60 millimeters, and that's the default unit. You can also enter, when you're doing this is an important thing to understand, you can also enter 2.5 IN for inches, and it'll convert it to whatever your system is. So you can enter in multiple different units so long as you have the abbreviation right. But I'm going to leave this at 60 millimeters. Okay. So we have a sketch. The other thing that you notice is we went from, I'm going to undo that so that you can see the difference. We went from a blue circle to a black circle, which doesn't seem very significant, except that a black outline means something is fully defined. What that means is if we take just a rectangle and we just put it somewhere out here in space, clicking for one corner, clicking for the other corner, what we have to do for the software to understand and have full definition, is what that's called, is we have to not just give it dimensions. So how wide? 50 millimeters. How tall? 25 millimeters. Give it a simple 2-to-1 ratio. Well, we've defined the dimensions. The problem is the software doesn't understand where this is yet relative to the origin or the coordinate system that we're using. So as a dead minimum, we have to select the point of the origin. So in this case, we're not drawing a continuous line. We need a point from the origin. And in order to really properly define, depending on how we drag it out, this is why I wanted to show you an example like this. If we drag it out this way, this is a diagonal dimension. Often that's not actually very helpful. Most of the time what we need to do is drag it straight down or left and right horizontally to keep it exactly the same height. So we'll start with the horizontal example here. We're going to draw it out horizontally, even though we're setting a height. So we're going to say 35 millimeters from the origin to the edge of this corner. Now, in this case, we've fully defined this now because it's changed to black. We want to be paying attention to that because that will allow our sketches to be more easily altered after the fact. So if we do a bunch of work and then have to go back and redo things and it can make a mess. So good habits involve making sure that everything we do is fully defined as we go. So I'm going to go ahead and delete that because what I want to do is I actually want to make this shape into something that would resemble the base of a drink holder if you're looking at it from the top down. Now, in order to do that, I need multiple circles. There's a bunch of ways to do this. For now, I'm going to show you a simple method. So we're still in the Smart Dimension tool. The other thing that you're going to use a lot is the escape key. When you hit the escape key, that goes away. We're no longer in the Smart Dimensions. Sometimes you're going to have to select tools multiple times. There's a special case of a line called a center line. So if you click the drop down, you can find a center line. So that center line, you'll also see these kind of dotted lines and leader lines, or what they're called, these leader lines, to give you an idea where you're still in line horizontally or vertically. So I'm going to zoom in and zoom out. Another thing you guys are going to need, before I forget that, is a mouse. You guys are going to need a mouse for all of this. So make sure that you've got the circles and the center lines set up. And then we're going to make a couple other circles with those center lines as well. Okay, so we've got a second one that we're going to do, a second center line. So let's do this. So I'm using the leader lines kind of off to the left side. I don't necessarily want to associate it with that point, just the center line here. What this is going to do is this center line, because we've fully defined the circle, these two center lines are fully defined. Center lines, it doesn't always matter, but you want to know how far apart these are. So somebody who's pretty quick at math, how far apart do we need another center line in order to make room for another circle with a 60mm diameter? So you wondered at some point when you were ever going to need math again. Well, turns out math is actually useful for things like adding up why on earth groceries are like $50 a bag at Walmart. Used to be Whole Foods prices, and that was like a couple of years ago, not like 32. So we have a 60mm diameter. How far do we have to go there? Any guesses? I'm talking about this dimension right here. First question to start thinking about is, if the two circles were going to be touching, how far apart would those center lines need to be? Good, 60mm apart. So we know 60 is the minimum, but a drink holder's got kind of a little bit of space, right? About 10mm or so. So what does our spacing need to be for these center lines? Needs to be about 70mm as a minimum. All right, so same deal. I'm going to go ahead and delete this rectangle. So you click and drag, and then you can hit the delete key. The reason you're going to need a mouse for this class is you're going to need to be able to zoom in and out. Trying to do it on a trackpad. Trackpads were made by the devil himself, so they are all terrible. I don't care who makes them, whether it's Apple or whether it's a Chinese manufacturer, whether it's a computer off of wish.com. They are all disastrous. All trackpads, all of them. So I wouldn't recommend trying to do SolidWorks with them. We're going to need another center line. And because we want this to be what's called a square pitch, you guys are learning all kinds of things today. A square pitch reference means the whole spacing, center to center, is the same in each direction. So it's the same in the X and the Y. So a square pitch is often used for things like heat exchangers, stuff that probably some of you guys care about, like intercooler bar and plate spacing, some of those sorts of things. So now we can add, these are 70 millimeters apart, both. You can zoom in and out using the mouse wheel if you've already got a mouse. If you don't have a mouse, get one soon. So we need to move using the smart dimension, the center point of that relative to the line. You can see here comes out as 0.73. We need to set that to 0 so that our distance, let's see, we need to set this distance to 0. Yeah, every once in a while, because the center point, this is a very interesting, it's a very interesting problem. I'm going to not explain why this is in full detail yet. I'm going to select that dimension, but I need to select the dimension itself by clicking the arrows and hit delete. Then I'm going to zoom in. I'm going to step out of the smart dimension tool, and I'm going to click and drag this in order to be coincident with this center line. So now it's coincident with 2 different center lines along 2 axes. Okay. So knowing that, what we're going to do is we're going to have, we're going to set the diameter using smart dimensions again, 60 millimeters. Mac and SolidWorks is an art form for you guys that have Macs. You might need to stop by Dr. Quarterwitz's office in order to get some assistance. It's possible Dr. Kong can also help with that. Those are the 2 that I would go to ask questions. But yeah, Macs are, because Apple knows best in all things, in all matters in life, Apple knows best. They will make all sorts of assumptions on the install, and it's sort of a pain. So we don't recommend students use Macs, not because they're horrible computers, just because they're a pain to deal with. That's all. A lot of parents are well invested in Apple stock and all those things. So they're okay, but you can't go to the tech squad because the tech squad is a bunch of fellow students who don't really know their way around computers to help with those. So yeah, Mac install problems, especially for those of you running the M processors, doesn't matter which M, any of the M processors, you're going to have issues with in order to get stuff up and running. Once it's installed, then typically it's fine, but that actually conducting the install, there's some special steps you have to go through, and that's just simply not a thing that I can cover during class, because then we just wouldn't even have class. All right, so we zoom in and out, we zoom in really far, and we hit the center point of the, we hit the center point here of the interaction, so you can see how far I was zoomed in there in order to be able to really control where that center point hits. Then I fix this with the smart dimension, and we're going to say 60 millimeters again. Okay, so that was a lot of work to put that together, but now we have, I'm going to move this sketch downward. There's a couple other things that will happen if you try and like click the scroll wheel. That does a different thing. I'll show you what that looks like. If you click the scroll wheel, you start rotating things in 3D, and very quickly people get seasick and lost, and then they don't know what's going on. They don't know which way is up and down and left and right and all the things. So when that happens and you bump stuff and you get lost, you come back up to this window and you can find a front plane. It'll give you a preview, or you can find a top plane. So I'm going to go back to the top plane view. You can also find it here with a label on the square, and you can move it around and find the one that you're looking for. So top plane view, I'm going to select that one. And that reorients us and fits the sketch back to the original size. Some of you will also do something like this, and something like this will happen, and then your screen will look like this, and you'll go, where did my model go? Oh no, I'm going to die. You actually won't die. You can use either the F key or you can use the zoom to fit up here. That will bring it back into view, and then you can slowly start zooming in and figuring out what happened, especially if you're trying to do this on a trackpad because you're glutton for punishment or something like that. Get yourself a mouse, even if it's a cheap USB mouse from Walmart. Maybe now's the excuse to say, hey, mom and dad, you know that gaming mouse I wanted? Yeah, I actually literally have to have it for class. Why? Because, 3D drawing is precise. Look, I'm just looking out for you guys, okay? If it happens to have RGB, that's okay. There's lots of great mice on wish.com. Probably not. So things to keep in mind there. You want to then, if we're trying to make a drink holder here, we're going to add a rectangle. So I'm going to change the dimensions of the rectangle. If you use one of these leader lines and you click, what this will do is this will set something called an association with the points, and it will fix some of the X and Y values. I don't want to do that yet, so I'm going to bring it out away from all of that stuff so there's no leader lines. And I'm going to bring it out and around and above so that, again, it's not associating these points with anything else. What that does is that starts anchoring the points so that the rectangle won't freely move the way that we want. So right now, if I hit escape to drop out of that tool, I can grab this rectangle and freely move it around and position it roughly where I want it. Okay, that's not so bad. So what I need to do is I need to center and move things around. In between these, another thing that I can do is a reference point. I can set up yet another center line. And what I'll do is I'm first going to move this rectangle off to the side so that it's not in my way. I'm going to add another center line. I want it to be referencing these guys, but what I want is I want it to be spaced evenly between them so that it's truly a center line of the thing that I'm drawing. Okay, so that spacing is 70 millimeters. So half of that is 35 millimeters exactly. So now I have a center line to use. I want another center line in my sketch down here, and I can bring it out as far as I want, so long as it stays horizontal. You'll see with your smaller cursor, This big size does all sorts of strange things. You'll see a yellow line that has a bar in it. That's indicating that the line is horizontal. You want to make sure that it's horizontal. And I'm going to set the spacing between this center line and this center line to be 35. So you can see based on the couple of millimeters there, now we can kind of roughly position this where we want it to. I'm going to set it slightly off center so that when we move it with the smart dimensions, I'm going to find the center line. Sometimes you'll have to click this tool a couple times in order to get it back. But there's a center line right there. So there's a special logo that appears that's a diagonal with, so there's a vertical, there's a center line, and there's a horizontal that's a bar that way. So there's a couple things there. I want to touch the center line and the center line here with my smart dimension, and I want to drop, okay. I don't know why it's not sharing with the cursor at all. That's a problem. Even in the settings, I don't think they changed that. It's part of why I'm trying to explain as I go. Yeah, even in yeah, even in the settings, I don't have a way to enable that differently. Yeah, it doesn't give me another option for doesn't give me another option. Maybe if I turn annotation off, let me see if that helps. All right, you see if that helps. So in the this dimension, I want to shrink down to 0 as the difference between the center line of the rectangle and the center line that's in the center of our object. Same sort of thing we're going to do here. I'm going to find the center line of the, there it is. So center line, so that's the thing that changes. I'm going to set that dimension to be 0, and that will move the rectangle to be proportional. Now, I can't move the rectangle. So if I hit escape twice, I can't move the rectangle. I can only resize it because I haven't fixed anything, but it's going to stay the same size with respect to these center points. It's going to stay the same dimension. That's why these associations are very important. I would zoom in on those, but they won't get any bigger. It won't help you. So these dimensions, exterior, again, sometimes you have to hit escape or hit that green check mark to get rid of that previous tool in order to be able to use any of this. Width is going to have to be at least a little bit bigger. So again, if we use our 10 millimeter spacing, somebody who's good at math, tell me what our exterior dimension needs to be here. So if we have 60 millimeters for both cups, we have 10 millimeters in between. We need 10 millimeter spacing on either side. What does that look like? Good, 150 millimeters. Same thing on this side. So you noticed now the left and right side, I'm going to zoom in a little bit so that you guys can see it. The left and right side are now black bars because those are fully defined. The thing that we now need to define is the distance between the top and bottom line. So since we're keeping that square, it needs to be the same 150 millimeters. Okay. So now we are one operation short. Our sketch is complete and fully defined. So we've used a couple of our different tools here. We've used our smart dimension. We've got a simple example. What I want to do for a few minutes is pause and see what questions you guys have and make sure you guys are having a chance to get caught up. So what questions do we have? Yeah, it's not showing the cursor at all. That's really frustrating. Okay. May have to see if there's something else that I can do. I shouldn't have to have a third party add in. That's utterly ridiculous. Because here's the funny thing is, does anybody know what the actual software backend? Um, um, any kind of mouse is generally going to be okay. What you want to focus on is probably go with simple rather than complicated. Physically, my hands don't work well with the super tiny, like carpal tunnel mice that come that are like cute and have funny cartoon characters on them. That's not helpful. So instead, what I want you guys to focus on is I want you guys to focus on getting a decent mouse that fits well in your hand. And a USB mouse doesn't require batteries. You don't show up to take a exam that morning and the batteries are dead, or the stupid USB dongle isn't there or something. So fewer things to lose when you get distracted throughout the semester, generally better. So I don't recommend wireless mice because of that, because it's usually not a big deal. Macs that don't believe in having, like, IO ports for things, now you have to carry around extra docks and dongles and stuff. It's just a frustrating ecosystem to work with. So if you're working with a Mac, you just have to deal. But the good news is a lot of the USB docks have lots of options for how to deal with things. So you want to get a mouse that works for you. It doesn't have to be RGB and have lots of extra buttons. One of the ones that I used as a go-to, carrying around with me in a backpack and whatever, one that I can beat up and not care about. It was like a $20 Patriot Viper mouse or something. So it's still a good, decent size, simple USB mouse, and it was like 20 bucks. I'm sure with inflation, that's like $200 now because, it's been 2 weeks. But any mouse that's reasonable and USB should work for this, because you want to be able to use things like the scroll wheel. One of the settings that you're going to want to also pay attention to is under properties. No, under up here at the gear under system options. What you're going to do is you're going to search for mouse, and it'll say mouse speed, or this one, the reverse mouse wheel and zoom direction. I have that checked so that when I the way that they do it as a default is if I push my finger forward, to my mind, that's zoom in, get closer, pull it back to me is zoom out. That makes sense to my mind. If you don't click that reverse, it goes the other way. And so you're pulling towards you to like pull the thing towards you. And that to my brain is completely backwards because of other drawing softwares that I've used in the past. So I have an override that I can't easily do because reasons. So there's a few things to keep in mind there, and there's a lot of reasons why you want to be able to use that mouse. For the week 1 assignment, let me take a look at what the names are, because I know there's still an open revision going on this class again. That's why they call it continuous improvement. The intro to SolidWorks, there is an attachment with documents. So I'm about to, there's an attachment that looks like this. Let me share that instead. This one. All right. So this one is, there's a few things that you're going to make. So if you turn in this assignment that we're working on now as an exercise, that will not be correct. Things you got to do are a rectangle for the first one. You're going to do a circle for the second one. You're going to do a silo for the third one. So we're about to see how these operations, and this is just a geometric shape. So you're about to see what these operations look like. They're showing a 3-dimensional height. So this is doing an operation to the 2D sketch, and that's where we're about to go. That's why I wanted to check in and see what questions there were. So you want to actually make the 3D objects and then take images. So it's a good segue to our sponsor this week, how to turn in assignments. So turning in assignments is going to be a Word doc. You're going to take screenshots of your produced thing. So in this case, I would take a screenshot of the base sketch. Something like Snipping Tool is going to be the best for that, or some other similar tool to be able to grab a screenshot of whatever that is, and then you're going to include that in your Word document. A lot of times there's going to be questions in the assignment itself. There'll be, I think, I want to say for like sketching basics. No, maybe it's some of the tutorials, I think. So introductory tutorial. Yeah. So the introductory tutorial has 2 questions that it's looking for written answers on. And it's asking about, why do you think these tutorials are useful? Those kinds of questions. We want you guys to answer those. There are points in the rubric associated with them. Students miss them all the time. But for this one, for this particular assignment, you're going to make these geometric shapes. So you're going to make a ball, and we'll show you how to make those shapes. That's part of what today is covering. So we're going to go back to this. Back to SolidWorks. Yeah. So there. Now I've got at least part of it again. So let's see if, all right. I don't know if you guys are seeing cursor or not. This is a Google malfunction today, it looks like. Thanks, Google. Be a better overlord. This is a feature. So this is what I was talking about doing an operation to a sketch. We're going to use an extrude. So an extrude base boss, what that does is it allows you to take a 2D sketch and turn it into a 3D object. Now, because of the way that we've done this, because of how I've designed the spacing and everything else, the software is going to kind of cheat for you and say, oh, I see, you're making a plate with holes in it effectively. Sure. So it's going to default always to a blind extrusion from the sketch plane, 10 millimeter depth. What that means is 10 millimeter thickness of that geometry that's selected. You can control the geometry by selecting these selected contours and actually filling in. Actually, I want this region. So the region highlighted purple is what I want. Maybe I only want to do two of those holes. So I select these two regions. And now it will extrude that face with only two holes in it. Or I can select this region, and now only one hole will be left in the plate. Or I can say, clear all my selections, start over. I got the wrong ones. Maybe I only want to extrude the geometries contained by these circles, and I want to leave the plate alone. Lots of different directions and things. You can switch the direction by using the direction arrow. So now it's going down instead of up. Now it's going up instead of down. You can also do tapered extrudes. We're not going to do those today because we're just going to get to the basics. So a lot of these are going to have somewhere between like a 10 and a 25 millimeter extrusion depth, but we want to extrude the actual cup holder region itself. So we want to select region 1. If for some reason thin feature is checked, that means there's some issue with the sketch or there's some problem. It's not going to extrude correctly. You don't have a line connected to another line. Something is open and it's an undefined region. So there's some fundamental problem with your sketch. If thin feature comes up, deselect it and see if it'll let you select an enclosed region. And then if it doesn't, you want to zoom in and look at all your corners and make sure that the lines actually touch and things like that. So once you've selected the right regions and you've selected the right things, another tip, you can actually hold the control key and click down the scroll wheel on a real mouse and move the sketch around so that you can recenter things more easily. That's really helpful instead of having to go back up and finding the move tool. I don't even know where the heck the move tool is because the hotkey is so much more useful. Yeah, anyway, there is a move tool. I think it's under there's another other toolbar where you can change cursor functions. I don't even remember where it's at. I don't know. I always use the control key because it's way easier. So when we do this and we hit the check mark, that will complete our extrusion and take our 2D shape and make it a 3D shape. We're going to ignore for the moment that the drink holder should have some sort of base to it. We're just going to show kind of the basics of how we use these sketch. Then I'm clicking the scroll wheel down to be able to show you in 3D what that looks like and what that rotation looks like. So we have it in 3D, and that's the simple example of the extrusion process. You can do additional extrusions from that base sketch. We'll deal with how to do that later because we're constrained for time today. But I want to show a couple other things. So I'm going to start a new sketch. Usually by the time we've gotten 2 or 3 pieces into our 2D sketch, you want to save sketches. In this case, I'm not super concerned because this is just a demo. This is something I can recreate very quickly. At least if I'm not explaining step by step and making sure everybody's still awake, all those things. So we're going to do another sketch, but we're not going to do it in this same plane. What we're going to do is we're going to do File, New, and we're going to make another part. So a lot of times students kind of, again, have a panic attack here. Wait, what happened to my other part? What happened? If you go down here to your SolidWorks bar, part 1 still exists. Now you also have a window with part 2. So it's just multiple windows, just like if you have multiple browser windows. This stuff should be fairly self-explanatory to you guys that have grown up with apps for all the things. This new part is going to be another thing that you're going to need as a revolve. And we're going to show you how to use that one to make a ball type shape. So we're going to come back over to the Sketch tab. We're going to hit Sketch. In this case, we're going to use a front or a right plane. We'll use front plane since we used top last time. And this is fairly straightforward. We're going to select a circle, hit the center point, hit the outer edge, and we're going to give it some dimension. Today is the day for 60 millimeters. Okay. There we go. In order to do a revolve of any shape, we need a center line. So what we're going to do is run a center line through, so I'm going to hit escape to get out of that tool. We're going to run a center line through this circle, and now we have what we need to be able to revolve this. With just a circle, you can get away with this. I'll show you another shape that you can't get away with this as cleanly. For this first assignment, you can get lucky and do a revolve on a circle. If you've got a center line present, it'll understand what you're trying to do because it can guess intelligently. So we hit OK, 360 degree blind extrusion, except you run into errors. So the problem is this revolve is trying to build a volume, but when it revolves 180 degrees, so we could tell it 180 degrees, and this it can sometimes do, but it's giving us an error about internal volume conflict. The reason is we need to go back to this sketch and edit it. So we're going to go back to the sketch. Yeah, all right, so we're in the sketch again. We're going to go back to the front view, so everything is square again, make life easy. We're going to add a dividing line to make this a semicircle. So if you're going to do a revolve on a shape, you need to use half the volume, because what it's trying to do is it's trying to revolve the shape by creating a volume, but it then creates a volume 2 different times when it goes 360 degrees. So the only thing that you could really do without having a dividing line is maybe about 90 degrees, because it would understand a 90 degree slice of a sphere. When we do it this way, we go back to features, we say revolve, you select the region, and you say, I want this to revolve. See, it's giving us our thin feature thing again, which we have to turn off. Always turn off thin feature. Thin feature is the devil, and I have yet to come across an actual real world scenario where thin feature is a thing. This is a, like, it exists for a reason, but I can't tell you what that reason is. And I've built many thousands of things in SolidWorks that I've also turned into real life parts. And I have yet to actually successfully need the thin feature. I think that is for effectively revolving shells, but there's better ways to do it than the thin feature tool. And we'll get to those later in the semester. So 360 degrees, sketch region 1. The line, we're going to use center line, which is what's called line 1. So that's all correct. We hit the check mark, and now it revolves with no problem. The reason is if it rotates the semicircle through 360 degrees, it does not cross any point of the geometry multiple times. Anything that causes any kind of intersection at all will not revolve correctly. So let me go back to the base sketch. Couple ways we can do that is you can right click, or you can click the sketch, hit edit sketch. You can right click and hit edit sketch. This will drop us back into the sketch itself. We're going to go back to view, hit front view again so that we can modify this. What I'm going to do is actually, I'm going to scrap the circle and go to another geometry. So I'm going to use a slot, which is one that you will also use for this assignment. So I'm setting the center line for the slot, and now I'm setting the geometry. I'm also going to make sure that it's off center because just because, in order to show you that you can revolve things that are off center and uneven. We just want to set a couple of the dimensions. So 45 millimeter, and we want to set the diameter. So this yellow line, when you go to start using smart dimensions on things, this means that something is over-defined. So because we know the height, we don't also need to set the radius of the semicircles. What we do need to do is set the distance here along the x-axis, and we're going to do 3.14 because lucky happenstance. So now the origin of this is defined. We need the actual overall width of this to the center line, and that needs to be, we'll say 40 millimeters. Some nice round number. Okay, so we have a fully defined sketch for this, or actually no, this one's not fully, yeah, there we go, fully defined sketch. We had to get out of the smart dimension tool. Everything was dimensioned, and that's why it was still blue. You step out of that, shows all black, which is fully defined. So now what we're going to do is go back to our revolve, but we have to step out of the sketch first. So hit exit sketch, revolve base boss, and it's going to make some assumptions. So because we've already executed a revolve and because everything was defined, if I delete this and I redo the revolve, it will show me, again, sometimes you have to hit it twice because reasons. I want this wider region to be a revolve, and I want the axis of revolution to be the center line in sketch 1. I want to get rid of the thin feature because it's the devil. The reason thin feature is showing up is because I didn't define exactly where these intersection points were in gory detail. So we hit OK. Now we have a revolve. The reason why I want to maybe do some kind of off-center thing like that is I may want to make a shell of this. There's another operation that is the opposite of the one that you just did typically. So there is an extrude, which means to add material, like you're 3D printing. There is an extrude cut, like you're drilling or making a hole, or cutting with a router or whatever. So you can add material based on the shape of your sketch, or you can take away material and cut away material based on the shape of your sketch. Similarly, you can add material like a 3D printer revolving, or you can take away material like a revolve cut. So I'm going to do a quick revolve cut, and I'm going to do it from this base sketch. I'm going to do a revolve cut. I want the axis of revolution to be this, but I want this region to be this region, So this will all make sense in a second, or you'll just think it's the ravings of a madman. Either way is fine. So what I've now done is I've created a hollow that is in fact a thin feature. So if I go to view, I can view this as a wireframe with internal dimensions. So this region, this thin region, I've now made effectively one layer of an onion almost, right? So an easier way to view that is going to be to go back here to have all of the edges and do another view trick, which you'll use later, called a cutaway. So in a cutaway, in a half cutaway, you can see, as I pull this along, what that region looks like. So it's basically the skin of an onion. By doing revolve and revolve cut, by doing extrude and extrude cut, I have precise control over a very complex geometry with only a simple few dimensions of the object that I'm working on. So here again, I'm really not sure what to do with the thin feature thing literally ever. So I'm going to hit X to drop out of that because I don't need a section view. I'm going to go ahead and undo that cut revolve by deleting, but I just wanted to show you an example of, for all of the operations, there is mostly a counter operation in the features. So the features are things that you do to the geometry of the sketches. The sketches are the things where you include the detail. So you get as much detail as you can in the sketch, and later on at the end, because part of this class is going to be you guys taking an exam. You're going to be taking an exam that will have some independent. It's an independent certification test that is an actual resume bullet that can, in fact, get you guys hired for a job because you have, hey, I'm certified in SolidWorks. I understand how to do things. Even if that company is not using SolidWorks, they can independently verify when they go to hire you that you have a real valid certificate. So this is not just another college class. This is how I'm teaching you to actually do stuff that you're going to use in real engineering. So I'm not talking because it's fun. The things that I'm teaching you for a specific reason. They're all to get you guys thinking in terms of how to create things in 3D, but to do it efficiently with your time, because the test itself is timed. And by teaching you guys efficiencies in how you make your models, efficiencies in how you go from sketch to finished detailed item, the more features we can get you guys to include in one sketch, the more we're going to be able to get to complex 3D geometries later on. Okay, so this is another good pause point. Questions? Where are we at? You guys generally following along, understanding the revolve and the extrude? Give me a 1 to 10 scale. So this is going to be the clarity scale. So 1 is like dry dirt, no water at all. I can't see through this. I'm not getting anything. You're like speaking in German, dude. I don't get this. 10 is perfect clarity, which we've deemed holy water. Somewhere in the mid-range, around like a 7 or 8 is like OG Gatorade flavors. Somewhere around a 3 is like Crystal Light. It's not even a real drink. Where are you guys at? Okay, good. I'm shooting for an average of about a 6-ish, and it looks like we're there. It's almost like I've done this once, twice, 350,000 times or something like that. Okay, good. All right, so we've covered a couple fundamentals about sketches. We've covered a couple fundamentals about I'm not going to get into planes and all sorts of other stuff today. Let's get into an example of a more complicated shape and how to use that. The revolve turns out to be a very, very useful tool for a couple things. So I'm going to do another new part. Okay, it looks like we are probably averaging somewhere around a 6.5-ish, maybe 7. So that's pretty good. All right, so one more new part. We're going to add a sketch. This time we're going to do it totally differently and go for the right plane. So we're going to start out with a rectangle. And I'm going to add the rectangle here. And then on top of that, I'm going to add a hexagon just to be different. Yeah, I'm going to add a hexagon, and I'm going to do center to corner like this. So I'm going to set the base dimension now. Let's make this 35 millimeters wide. And let's make the overall height from the bottom edge to the top edge. Let's make that height 110 millimeters. Okay. So even without doing any deleting or anything else, we're going to take advantage of a revolve in order to replicate something, which means if we're going to use a revolve, we really need something resembling a center line. Hit escape to drop out of that tool. And we are going to hit revolve base boss. This is where we're going to come into a problem, but we are going to need a bisecting line. So I'm going to go back to the sketch, and I can add this without on an angle without ruining everything in the universe. If you guys try and start getting fancy and adding center lines and things when the sketch isn't, when you're not looking squarely at the sketch, you're going to cause yourself some headaches because you're going to miss some references. It's real easy to do. It's perspective is hard. You really need to be in the correct view orientation to be able to get this correct. So what we're going to do is we're going to revolve this. Let's go back to features and revolve. We're going to select all three of those regions and revolve around the center line. Hit OK. So we have created our milk pail here as an object. By keeping careful control of center lines and having a dividing line to avoid the geometry conflict, we can do what we need to here in order to get a full featured geometry put into place. Okay. Given that, here's the next thing that we're going to do for that. When we go to take screenshots, for instance, we're going to click the object and it's going to show us a couple dimensions. It's going to turn blue. This is one of the things we want to screenshot in order to paste that into our Word document. So we started talking about Word docs. Make sure if questions apply, you put the 2 questions up at the top. Make sure your name is on it, and make sure it's not, untitled document 3652. Otherwise, I'll know why you can never find the assignments you're looking for. Creates all sorts of headache that just aren't worth it. So don't do that. All right. Having said that, we've got a couple other things that we'll want to do. Any questions on this kind of simple revolved cylinder or something like this? You guys feeling like that's pretty straightforward? Okay, it should be. It's always easier for me to do it on the board. When you go to do it yourself, sometimes you can go, wait a minute, this is not as it was advertised. All right, so that's a simple revolve. Trying to think of, there's like one or two other things going on. So you have to do a simple extrude, you have to do a simple revolve. One more thing that you'll have to do is you guys might get stuck on a geometry. Let me do one more thing so that you guys see it. So one more new part. Sketch. This one will be on the top plane. So let's say you had a shape like a rectangle and you had a, let's say theoretically, you had some kind of a hole that was a hex key because this was a crank or crank arm or something, right? Lots of different kinds of things actually do look like this in reality. So this is just a simple example. We set our smart dimensions to be 65 millimeter, and maybe it's a really long ratio, maybe about 130 millimeters. Let's do a little longer than that. Let's do 150. Okay. This guy, center line for leverage is 115 millimeters. This is halfway through that thickness. So now the center line is specified, and let's do 22.5 on each side. All right. The 22.5 is specified. I have X and Y specified. The angle, I think it's this. Yeah, it's that distance. So it's trying to get a vertical distance. Here, we could actually say this needs to be 20. And that sets the angle or orientation. So maybe this is slightly off angle. I'm going to undo that dimensional change so that it's got a pitch. Because these are essentially these hex shapes are an overly fancy circle. So we'll get into angles and things later. That's not necessary for week 1. But for this kind of hex key geometry, this will work okay. Now that we've got it fully featured, we're going to do an extrude. And let's say you extruded both regions. So this region and this region. And we extruded that by, let's say, 20 millimeters. Okay. But the object you were supposed to draw has a hole where that feature is. You can do the reverse by hitting an extrude cut. Select your part tree drop down, select the feature that you just used, or the feature that you just did, and you're going to click sketch 1. So this is where we're going to do the cut from, is this base sketch. You're going to select the region. So it's not going to be the whole of sketch 1. It's just going to be this hex key geometry. Only that cut operation is going the wrong way. So we need to flip it and go the other way by 20 millimeters. Another way that you can ensure that it goes through is you can say through all or through all both if you need a cut to go through all sides. So to make absolutely sure and certain we have a cut, we're going to do that. So now you've got unstuck on your geometry that you're working on here. Okay. So that's a simple example of how to use a boss extrude. You can do this in one operation. You can also do this in two. Sometimes the boss extrude, especially if you have an issue with the second sketch or something, sometimes it's just easier to do a boss extrude and then a cut extrude, because it just is. So whatever method there makes the most sense to your brain, you can use either one on the next assignment. So, all right. That covers the core fundamentals of what we need to actually do for the lesson part of it today, to get you guys started. We're not going to use any of the fancier steps at the moment, but this at least gives you an idea how to go about doing the assignments that are in the homework. All right. So, any further questions on this? Any points that you're like, wait a minute, I didn't understand that at all? Nope. If so, go ahead and type those into chat or unmute and pretend like you're a human. I know you guys say all sorts of unkind things to the other 12-year-olds' moms on the video games, but so I know your mics work, but yeah. All right, so this covers the basics for how to get started on these assignments. Let me see if there's any others. Tutorials, that's another one that I'll have to show you where the tutorials actually are. There are a couple ways to get this. Another thing that I'll recommend is up here, you can pin the bar. I highly recommend doing this just so that you don't lose it all the time because reasons. You can also get to your different parts that are all open by going to window. So off to the right side of this interface, we haven't used this a whole lot yet. There is a menu. So if you look at SolidWorks resources over here, that's a little house. There's a couple things that are helpful. There's a couple kind of general suggestions. There's a design library that has some pre-built content. There's file explorers and some other things. There are there's the palette. This is a view palette when you go to do assemblies and things later. There's also appearance stuff that you guys can do to change how that works, and then you can set properties. We will get into how to set materials properties later. We're not going to try and do that all right now because too many other things, and because I have these time conflicts during the next this week and next week. We're going to be a little abbreviated on time for this class. Hopefully that will all get resolved. There's a couple other things that that you can get to from up here. So I'm going to go ahead and close this. So that's what this menu does. You can click home. That's going to be the easiest way to get back to the tutorials, is to click the home screen. There's other ways to do it, but this is going to be a whole lot easier. So at the top, there's home, there's recent, which is what have you been recently working on? What have you recently saved? I didn't save any of those, so those aren't saved. And learn. This is where you're going to come to be able to get a look at what's going on here. So getting started with SolidWorks CAD is kind of their learning lessons. The tutorials, you're going to get a second window. Let me make sure it's showing up, because if not, I'm going to have to do, I think for next week, I'll do window share, and that'll fix some of the issues. Yeah, it's not correctly doing that. Okay, so I've got an idea how to fix the mess. I'll have to do window share differently next time. So the tutorials panel looks like this. And this is where you're going to find the tutorials panel. So in the tutorials panel, you've got getting started, intro to SolidWorks. This is where most of that's going to be. Parts, you will have a bunch of parts, but intro to SolidWorks, this is the actual assignment that's going to that you're going to be working through. You're going to be walking through these, and it's going to show when you click on the button, it's going to show you, it's going to highlight it where it is up in the window. So it's going to kind of walk you through a couple features, and it's going to show you step by step how to actually go through, make these parts, how to do some step extrudes, step by step, how to use the countersink for the screw heads and a couple other things. Then it's going to have you undo that and do a couple other steps, and then use an array command. So it's a kind of a complex piece that you're making, but it's a good example of how to make a complex part using just simple 2D operations. So once you're done, then you're going to create drawings, and it'll show you how to be able to actually do that. You can add center lines and all sorts of things, and understanding notation and things. So it's going to show you where all of these dimensions are, how to find them, etc. Okay. So this one looks like, so that's your tutorials. Going back, you can also find the lessons here, but it's going to be easiest to go back to the home screen. 850 steps later. There we go. So I'm going to hide that panel. Lesson 1, parts is one that you're going to use. Lesson 2, assemblies is one that you're going to use. There's also some under the basic techniques, such as fillets, revolves and sweeps, patterns, lofts. All of those are going to get used. Design tables, photo view 360 is an issue. We'll talk about that later. Not today's problem. Yeah, you're really not going to get, there is a CircuitWorks one toward the end of the semester. That's always super fun. There's also, under a bunch of these lessons, under the CSWP, CSWA prep, there's a bunch of analysis that's used. We really don't get into sheet metal and some of these other ones, but yeah, there are a few, and then there's just a list of all of them. There's some simulation examples too. We're not going to be using any of their pre-built simulations. I think simulations are all stuff that we've moved into class time in actual classes where things get applied. There's some other motion analysis, cam path analysis, and all sorts of things we're not going to get into, but this is where to find the SolidWorks tutorials, mostly under the getting started and basic techniques. That's where they all are. So you guys will no doubt ask later, but that's where the intro to SolidWorks, that's this assignment. So if you turn in another part, you won't be able to get credit for it. So that's pretty important. All right. I'm about to have to jump off and start this other class that I'm subbing for a couple weeks. So any questions so far? You guys feeling reasonably comfortable? Like you at least have a starting point? Okay, that's good. So the best next steps for you guys to do is make sure that you've got SolidWorks installed and go ahead and get into that Intro to SolidWorks assignment. Start getting some practical application. Any last questions or concerns or moments of sheer panic before we go to close out? All right. If not, then I will see you guys next week. I'll try and keep up with messages as they come in. Sometimes responses will be a little bit delayed, but we should be generally okay. And I think I know how to resolve that not being able to see the cursor issue. You'll still want it in the larger size because reasons. Yeah. So I will fix that for next week, and then we'll get it set up because it should always show with that window share, but sometimes it's buggy and problematic. Yeah, it's an issue. All right. So we will reconvene next week then. Like I said, there's a lot of other SolidWorks related content on that YouTube channel. So go subscribe to it. Make sure you can find the playlist for SolidWorks. And there's lots of stuff there. So if you guys want to start getting ahead or start getting into some of the further assignments and stuff down the road, some of the more aggressive techniques, if you guys have already mastered basics, go right ahead. All right. And I will see you guys next week.